So yesterday, we had our discussion about concentration, and we learned that when you say concentration, it is an intensive property, meaning it is not dependent on how much matter is being considered. So though we can actually do dilution wherein we can add more solvent to increase the volume of the solution, and it will result to a less concentrated solution. So yun yung diniscuss natin yesterday. I hope naintindihan yon. Kung meron kayong hindi naintindihan sa part na ito, you can ask questions, you can send your questions sa chat class and we will answer that. Okay. But for now, we will continue about gravimetric analysis and acid-base titrations. These are two quantitative analysis or methods of analysis wherein we can determine the amount of the substance or even the concentration of the substance. So let's start with the gravimetric analysis. So again, this one is an analytical technique wherein we can measure the mass of either the reactant or the product. All you have to remember is pag gravimetric, mass talaga. Ang mini-measure natin, it's the mass. Kasi sabi ko kanina, itong dalawang ito, the acid-base titration can either measure the amount, and that is in mass, or the concentration. So later, ang acid-base titration, we will discuss how to get the concentration for that. This time, it's the mass, but gravimetric analysis can be done only if the reaction involves precipitation. So there will be the formation of the precipitate, where we can isolate it and we can measure its mass. So without the formation of the precipitate class, we cannot really do the gravimetric analysis. And generally, this method of analysis is applied to ionic compounds. Kasi itong mga ionic compounds ang mostly nagpo-produce ng precipitate. So just a little review, pag sinabing precipitate, it's a solid, insoluble substance. Solution. Again, it's a solid, insoluble. Hindi nadidissolve. Kahit anong gawin mo, hindi siya madidissolve. That's a precipitate class, especially if you have reactions between two liquids. And then after that, the product will have a solid substance. So precipitate ang tawag doon. Now, how do we do the gravimetric analysis inside the laboratory? So first, we have a sample. We have a sample and it's unknown. The composition is unknown. So we don't know. Hindi natin alam kung anong chemical compound yan or anong chemical substance yan. Hindi natin alam yung kanyang chemical formula. It's a solid substance most of the time. And then after that, we will dissolve that in water and i-allow natin to react with another substance to form a precipitate. So in gravimetric analysis, since we have an unknown and then we will have another compound to have it reacted with, so magpili ta og compound class na sa tanaw nato mag-form siya og precipitate. So kung dili siya mag-form og precipitate, then we can look for another compound until na ay ma-form na precipitate. Now, once the precipitate is formed, we will get it, we will filter it, hihiwalay natin siya with the liquid substance. I-dry natin siya. Most of the time, we will use the oven for drying, and we are going to weigh the precipitate. So we will get the mass here. Now, knowing the mass and chemical formula of our precipitate na na-form, by that time, we can actually calculate the mass of a particular component sa original sample. So, di ba meron tayong unknown? Just using the mass of the precipitate, it will actually help us na malaman din kung ano ba ang possible na composition ng unknown substance na yon. So finally, from the mass of the component and the mass of the original sample, we can determine the percent composition by mass of the component in the original compound. So ma-measure din natin yung mass ng component ng original compound natin. So this is both for the identification of the unknown and at the same time measuring the amount of the component of the unknown. So meron tayong mga instances niyan sa laboratory na we don't really know what chemical compound is that. So pwede natin gawin si gravimetric analysis. So we have here, for example, though this one is not really unknown kasi we already have the equation. We have here silver nitrate. Tapos pinapareact natin siya with sodium chloride. We will have the following product, sodium nitrate in aqueous solution. So this one is the liquid part of the product. And take note of the S, it's solid. So we have here silver chloride. So the net equation for this, syempre the silver will react with the chloride. This one is actually a double displacement reaction. And then na-form si silver chloride. So parang ganito din class yung gravimetric analysis. As long as there will be the formation of a solid precipitate, we can push through with the method or the procedure. So in the laboratory, since we cannot really do this by now, we have here illustrations sa ginagawa natin. We have here A, B, and C. Sa letter A class, you can see there a solution containing a known amount of sodium chloride in a beaker. So this one here is a sodium chloride solution. And then the precipitation of silver chloride upon the addition of silver nitrate solution from a measuring cylinder. So itong nasa graduated cylinder class is the silver nitrate. And if we add the silver nitrate doon sa sodium chloride, as you can see, there is the formation of a white precipitate. Now, after the formation of the white precipitate, we can filter it para mahiwalay siya. And though hindi na napakita sa illustration, hanggang letter C lang siya during the separation of the precipitate and the liquid portion of the product or the products. Then, after kasi dito, may oven pa siya. So, pag nahiwalay na, i-dry natin. After placing it in the oven, na-dry na siya, pwede na nang i-weigh yung ating precipitate. So, ito yung process ng gravimetric analysis sa laboratory. So, this is actually a highly accurate na technique kasi makukuha natin yung mass ng ating sample accurately din. But, kailangan yung tandaan na we can only do this if the reaction will go into completion and that yung precipitate na ma-form will really be insoluble kasi may mga instances na though in the reaction may solid substance na na-form pero the precipitate will be partially soluble. So may mga parts doon na nagiging soluble siya sa liquid. So hindi na yun pwede for the gravimetric analysis kasi hindi natin makukuha yung 100% yield. So yung gravimetric analysis dapat talaga precipitation reaction siya and the precipitate is not soluble to the liquid. So 100% yield tayo. Now to give you a picture kung paano yun ma'am, paano mo ma-identify yung product mo na unknown yun. And then ano lang ang ginawa natin, nagpa-react, naghiwalay ng precipitate and then di-weigh ang precipitate and then ano nangyari? Paano natin na-identify ngayon yung component ng ating unknown? So ito yung sample problem class. So paki-ready na ng ating calculators dyan. And this one is medyo mahaba-haba ng computation. Meron tayong 3 steps for this. Again, sa pag-compute. So let's first read and understand the problem, we have a 0.5662 gram sample of an ionic compound containing chloride ions and an unknown metal is dissolved in water and treated with an excess of silver nitrate. If 1.0882 grams of silver chloride precipitate forms, what is the percent by mass of chloride in the original compound? Again, let us first list down the given so that we can decide what strategy are we going to use in solving this problem. So the first given here, you have the weight or the mass of the unknown. This is 0.5662 grams. We have an unknown compound, though we know that this is ionic and that it contains chloride, but hindi natin alam kung ano ba talaga ang kanyang exact chemical formula or ano ba ang kanyang exact chemical name. So yun lang yung alam natin, ionic siya and it does contain chloride. So since alam natin na meron siyang chloride, then we can the investigator here decided to use silver nitrate kasi pag chloride magre-react with silver nitrate plus, this will form the silver chloride, and silver chloride is always insoluble to water, so this will become the precipitate. Now after the reaction, we have here the mass of the precipitate. I'll just write PPT, that's precipitate. And again, the precipitate is the silver chloride. And this is 1.0882 grams. Now, what is the question? What is asked in the problem? It's the percent mass of chloride in the unknown. Ito yung hinahanap natin. So this is gravimetric analysis. So, ito lang yung alam natin, mass of the unknown, starting reactant natin, and then mass of the precipitate. Tapos i-compute natin yung mass of the chloride doon plus sa original compound natin, which is unknown. I hope naintindihan yung problem na yan. Kasi magsa-start tayo na sa computation. So yung strategy, meron tayong 3 steps for this. Step 1, let me write it sa screen. Step 1 is the computation of percent chloride. This time it's percent chloride kasi ito yung hinahanap in the problem. But this is not always chloride kasi depende kung anong ina-ask sa problem, kung fluoride, bromide, then palitan niyo lang ito ha. So, this time lang sa problem na ito, percent chloride in the precipitate. That's the first step. We have to look for the percent chloride in the precipitate and we will be using this formula. Percent chloride in the precipitate is equal to the atomic weight of the chloride in the precipitate divided by the molecular weight of the precipitate times 100. Okay, so please copy the formula na sinulat ko sa screen. That's how you compute for the percent chloride in the precipitate. Atomic weight muna ni chloride. So this time, ang ginamit class na atomic weight was not rounded off to the nearest whole number. Kaya kung makikita niyo sa screen, meron siyang decimal point. So in the quiz or in the exam, you just have to read carefully the instruction and follow the instruction. Kung ang instruction ko ay you have to round off the atomic weights to the nearest whole number, then you do it. So, wala dapat akong makita na decimal points. Pero this time lang, for the sake of the discussion, we will use the atomic weights na hindi naka-round off. So ito, percent chloride is equal to, class, if you look at your periodic table, 35.45 is the atomic weight of chloride. And then i-divide natin siya sa molecular weight ni precipitate. Do not forget na when we listed down the given, the precipitate there is the silver chloride. So if it is not given in the problem, you have to compute for the molecular weight of silver chloride. I hope by now, alam nyo na paano i-compute si molecular weight. Diba? Isusulat mo lang yung number of atoms present in the compound and you multiply it sa kanilang atomic weights. Okay? Kaya in this case, you have here 143.4 grams. Actually, it's grams per mole, but let's just use grams here. Since we are just looking for the percent chloride, ilang percent daw yung chloride na nasa precipitate natin. So this is 35.45 divided by 143.4 is 24. This is actually 0.247210599. Tapos i-multiply mo siya sa 100. Kaya nakuha natin 2 decimal places, 24.72%. Again, that is class, the first step. Any questions sa first step natin? Again, any questions sa first step before tayo mag-proceed sa second step? Wala. So let us continue. Let us continue. We have here the second step. Let me write it sa screen. Step 2. Computation of the mass of chloride in the precipitate. So yung kanina, percent muna ng precipitate na nasa percent muna ng chloride na nasa precipitate. This time, yung mass na talaga. Ilan kaya yung grams ng chloride ang present sa silver chloride? So how do we do this? Anong gagawin natin? The formula here is mass of precipitate is equal to the percent chloride. Wait lang, i-complete ko para dili mo malibog. Complete na ako. Mass of chloride, this one is in the precipitate, equals percent chloride in the precipitate times the weight of the precipitate. So yung percent chloride dyan, yun yung na-compute natin sa step 1. Diba? 24.72% yun. And then, i-multiply natin siya sa weight of the precipitate. Saan ito galing? Nasa problem ito, class. So, kung balikan natin yung problem, naka-state doon na ang precipitate na nakuha after the reaction is 1.0882 grams. So, i-multiply lang natin. But take note that 24.72 is in percent. So, we don't really multiply it directly. Diba? Pag percentage, ginagawa natin siyang decimal. So, para di mo maglibog, just go back sa decimal. I-divide din niyo siya sa 100. 24.72 divided by 100 is 0.2472. Kaya ito, 0.2472. Multiply natin siya sa weight ng precipitate, 1.0882. So we have here now the mass of chloride in our precipitate, and that is 0.2690. This time 4 decimal places na lang muna. 4 decimal places. So pero kailangan yung magbasa ng instruction during quizzes or exam. So ito lahat, class, yung chloride na nasa precipitate natin. So the last step now, this is the step 3 and this is the last step. We can now computation of the percent chloride in the unknown na. So ito na yung hinahanap. Okay? Computation of the percent chloride in the unknown. So, paano natin siya i-compute? Our formula is percent chloride sa unknown natin is equal to the mass of chloride, this is capital, chloride in our precipitate divided by the, wait na lang ang gamitin ko, weight of the unknown. Again, weight of the unknown times 100. Let's copy it first. Percent chloride in the unknown is equal to mass of chloride in the precipitate divided by weight of the unknown times 100. Now class, mass of chloride in the precipitate, ito yung na-compute natin sa step 2 and that is 0.2690 grams. And itong weight of the unknown, this is given in the problem. So if you copied the given a while ago, na nilista ko, you can see there that the weight of the unknown is 0.5662 grams and i-multiply natin siya sa 100. So wala tayong unit ha, percent lang yung unit natin dito. So 0.2690 divided by 0.5662 is 0.475097138 times 100. So times 100 and let's round it off to 2 decimal places. So we have here 47.51%. So ito na ngayon class yung chloride na nasa unknown natin. Remember, we don't know, kaya nga siya tinawag na unknown kasi we don't know the chemical formula of that substance. All we know is meron siyang chloride. And ngayon, alam na natin na yung chloride na nasa unknown is 47.51%. Kung 100% yan, 100 minus 47.51%, the remaining 52.49% of the compound is for the metal. Since this is ionic, the chloride is the non-metal. So yung remaining na 52.49% metal yun. And the gravimetric analysis will help us now to look for the metal. Kung ano yung metal na yan. Kasi na-narrow down na natin yung ating yung scope natin sa paghahanap. Basta ang amount niya is 52.49% and we will just look at the atomic weights kung ano yung kakasya dyan sa 52.49%. So yun yung gamit ni gravimetric analysis. So nag-start lang tayo sa product class and nalaman natin yung unknown na nasa reactant. Because remember, we have the law of conservation of mass. That the amount of the substance in the reactant will just be the same sa product. Kasi walang matter na na-create or walang matter na nasisira during the reaction. This is why we can use the amount of precipitate in computing the amount of the reactant. So nalimit na yung search natin for the identification of the unknown. Actually, gravimetric analysis will not really give us the exact chemical formula, but it's the first step in the identification. So hindi siya makaka-establish ng whole identity of the unknown, but again, it can help us narrow the possibility. Since we know now na 42% of the molecular weight is for chloride alone, then the remaining 52.something% will be now for the metal. So yun na lang yung hahanapin natin, yung metal. And that is through their atomic weights also, or we have other techniques used in chemistry with the use of sophisticated machines, makikita natin kung anong metal yun siya until malalaman na natin and marireveal na natin ang whole identity of the unknown compound. So that is now the essence of the gravimetric analysis. Any question? question, class? Or should I give you another example for the computation so that you can master the steps? Wait lang. Let me place here a blank muna na slide para I can have more space for the computation. Yes, Nicole, are you raising your hand?
Ma'am, yung ano, good ma'am, parang may, ano po yung parang general formula niya, good ma'am? Like, parang wala pa good yung mga, ang element, good ma'am? Like, formula lang good siya, ma'am.
What do you mean formula? You can just replace the formula with any element that is unknown in the, or that is asked in the problem. So, di ba, nilagyan ko ng mass of chloride in the precipitate. You can just replace chloride here, or chloride there kung ano yung hinahanap in the problem. Is that clear? So, for example, ang hinahanap sa problem is fluorine. So, palitan nyo yung formula. Instead of mass of chloride, then mass of fluorine. Ganun lang siya. But that's the formula na. I-specify ko lang siya. Okay, anything else? Before ako magbigay ng new example. Wala na? Lang ha, let me just type ko na lang siya. Chloride muna and then let's have another element later. Okay. Wait lang. Okay, please read the problem. You can copy the problem ha. And then try to answer first. Please follow the steps kanina na sinabi ko. And then later we will check if nakuha nyo yung tama na answer. Okay? Wait lang ha. While waiting, CR muna ako and then I'll be back. Please continue sa pag-compute. Are you done? Not yet. Apa?
At niya po, ma'am. Dissertation,
Ano na question mark? Dili sigurado. yung send din na question mark. Sige daw, let's try to answer this. Let's start first, syempre, with the step 1. Ano yung nakasubmit dito? Palma, Kokal, Zakaria, Bautista, Sarima, and Lozada. Sige. Let us try to solve this. Let's start syempre with step 1. Step 1 is the computation of the amount of chloride in our precipitate. And that is just the atomic weight of chloride divided by the molecular weight of our precipitate times 100. So atomic here, anong ginamit nyo? Whole number?
whole number, ma'am.
Whole number po, ma'am.
Okay, it's okay. So we have here 35 grams. And for the precipitate, that is AgCl. So this is one. What is the atomic weight of silver again?
108, ma'am, pag na whole number po.
Okay, sige, 108 and 35. So this is 108 plus 35 is 143 grams. So 143 grams times 100 is 35. Wait. Okay, wala na siya. 35 divided by 143 is 0.244755244 times 100. So this is 24.48%. That's the step 1. Now let's move on to step 2. So step 2, I'll just write it here. Step 2 is now the computation of the mass of chloride. So mass of chloride in the precipitate, and this is just the percent chloride in the precipitate times the weight of the precipitate. So what is the computed? 24.48% times the weight of the precipitate in the given. Yielded 0.56 grams. Okay, so 0.56 grams. Now, itong 24.48, naka-percent ito. So, gawin natin siyang decimal. Paano mo siya gagawing decimal? I-divide sa 100. So, that becomes 0.2448 times 0.56 grams is, let's have 4 decimal places, 0.1371 grams. So this is now for the chloride in our precipitate. So pwede na tayo mag-move on sa last step. So step 3 here is the percent of chloride in our unknown. And how do we do that? How do we compute this? For this, this is the mass of chloride in our precipitate divided by the weight of our unknown times 100. So the computed mass of our precipitate is 0.1371 grams divided by the weight of the unknown. What is the weight of the unknown again? 1.05. 1.05 grams times 100. So 0.1371 divided by 1.05 is 0.13057148 times 100. 2 decimal places, 13.06%. So ito ngayon class, yung chloride na nasa unknown natin. Ganyan lang karami yung chloride na nasa unknown. So 13.06%. And the remaining, the 86.94% na remaining, this is for the unknown metal. Kasi most likely, di ba, gravimetric analysis is for ionic compound. So alam na natin kung gaano karami yung chloride. The succeeding experiment will just be for the identification of the unknown metal. Okay? So nagkakaiba tayo ng percent class because sa pag-round off, right? But I hope the steps are correct. Sa pag-round off na lang yan, sometimes kasi nag-round off, hindi kayo nag-round off dito, or sa step 2, hindi kayo, 2 decimals lang yung ginamit ninyo. So 2 decimals lang yung ginamit ninyo dito sa step 3. So nag-iiba na ngayon yung answer. Pero sa quizzes and sa exam, magbibigay ako ng instruction kung paano kayo mag-round off sa steps para uniform tayo pagdating class sa final answer. Okay? Questions for this? Mali mong step 1. Any question? Let me give you, depende sa sa instruction ko, pero mostly talaga 2 decimal places yan sa instruction. Mostly 2 decimal places. Pero do not forget to read the instructions carefully and follow them. So let's have another example. This time, it will not be a chloride ang hinahanap. Yes, Rosemary.
Ma'am, ang sa atomic weight, good ma'am. I-whole number na lang siya tanan, ma'am.
Sa atomic, yeah, i-whole number na lang siya tanan sa atomic weights para uniform punta. Sige, you try this one. An unknown compound containing sulfide weighed 0.98 grams. It was reacted with lead chloride and produced 0.51 grams lead sulfide precipitate. How much sulfide is present in the unknown compound? So lead sulfide is actually insoluble to water, so it will really be a precipitate. So palitan nyo lang class, instead of chloride, palitan nyo siya ng sulfide. The same process, the same formula. Ay, sorry. Done na? Let us see. Let us see. Nga na may mga question mark siya. Dili mo sigurado tanan. Let us see kung kinsay tama ang answer ani. Kaya ang uban lahi mag-answer. Okay, wait lang. Step 1 sa ata. Step 1, the same thing ha. Computation of the amount of sulfide. So this time, ano siya? Percent sulfide in the precipitate. Atomic weight pa rin. So atomic weight pa rin ni sulfide over molecular weight ni precipitate times 100. Ganito pa rin yung kanyang computation class. So the same, kung titingnan ninyo, the same ang formula, pinalitan lang natin ng sulfide. So what is the atomic weight of sulfur? Kindly look at your periodic table.
32, ma'am.
32, ma'am.
32 grams. The molecular weight of precipitate, what is our precipitate? Here, it's lead sulfide. So, hahanapin mo lang yung molecular weight niya, class. Lead and sulfide. Ay, sorry. This is supposedly 1. This is 1. Sa isa lang sila. And this is 32. How about lead? What is the
207, ma'am.
207. So this is 207 plus 32. So this is 239. So yan yung gagamitin mo dito, class. 239 grams times 100. So 32 divided by 239 is 0.133891213 times 100. 2 decimal places tayo. So 13.39%. So that is the percent sulfide in our precipitate. So ang step 2, natin, the same thing pa rin. Pero mass of sulfide na siya in the precipitate. This is equal to percent sulfide in precipitate times weight of the precipitate. So yung na-compute natin is 13.39% times weight of the precipitate. What was that again? 0.51 grams. Okay? So 0.51, yung 13.39 gawin mong decimal, divide mo sa 100. So 13.39 divided by 100 is 0.1339 times 0.51 grams is 4 decimal places, 0.0683 grams. So yan yung sulfide ngayon. Mass of sulfide in the precipitate. You can have 2 decimal places, but para mas accurate tayo, let's use the 4 decimal places. Now, lastly, we'll have the step 3. And ganun pa rin yung kanyang formula. Percent of sulfide in the unknown is equal to the mass of sulfide in the precipitate divided by the weight of the unknown times 100. So yung mass of sulfide in the precipitate, that is the one that is computed sa step 2, 0.0683 grams divided by the weight of the unknown sa given one, 0.98 grams times 100. So let us divide 0.0683 divided by 0.98 is 0.069693877 times 100, and let's round it up to 2 decimal places. This is 6.97%. So yan yung sulfide na nasa unknown natin. The remaining 93.03% is for the metal. So, yan yung answers natin. Anong nangyari sa iba? Yung 6-something%, okay lang yan. Tama pa rin yan. Nagkakaiba lang tayo sa rounding off. Okay? Tapos, yung iba na malayo talaga, what happened here? Can please identify alin sa steps na yan ang namali ninyo. Kaya hindi naging malapit yung answer. What happened to the 7.41? Yes, Nicole?
Ano, ma'am, yung sa step 2, good ma'am, always i-4 decimal, ma'am. Gatula, man, good ko, ma'am, nung layo kaya kung answer.
It's okay. 0.06 lang ang gamit. 0.0.
Kasi, 0.07 lang yung ginamit ko, ma'am.
0.07 divided by 0.98. That's okay. I'll still consider that. 7.14. Okay lang.
Yes, ma'am. Thank you, ma'am.
Yung iba na malayo na talaga, yung nag 12% or anong nangyari dyan? Pag isulat ang answer, actually no need isulat yung percent ng metal. Kasi hindi naman talaga siya hinahanap sa problem. Pinapakita ko lang sa inyo kung paano nag-work si gravimetric analysis. Yung PbCl2 ang ginamit for the molecular weight. No, you have here class, pinangalanan talaga siya, 0.51 grams lead sulfide precipitate. So si lead sulfide ngayon yung precipitate, not the lead chloride. The lead chloride is just used to produce the precipitate. Kasi we have the unknown. So, di ba, ang process ng gravimetric analysis, unknown, tapos ipapareact mo siya with another compound to produce the precipitate. Pero in the computation, hanapin mo talaga saan dyan si precipitate. Paano nakuha si 93.03? 100. 100 minus 6.97. That is 93.03. Kasi di ba 100 is for the totality of the whole compound. Now, 6% of that compound is for sulfide alone. Therefore, the remaining 93% is for the metal. Yun lang, pinapakita ko lang yan. Pero actually, that is not asked. That is not really asked in the problem. So, hindi talaga strict na kailangan isulat mo din yung percent ng metal. Anything else? Any concern about this? I hope na sundan na yung process. Nagkakaiba lang tayo ng answer due to the rounding off. Pero nevertheless, if nakita ko tama yung process ninyo and sa rounding off lang tayo nagkaiba, okay lang. I'll still consider that. Yeah, the final answer is 6.97. Again, the final answer is 6.97%. By the way, class, there are instances na kagaya nito. Ano pa rin yung number, ha? So example, this is the problem. An unknown compound containing chloride weighs 0.98 grams. It was reacted with lead sulfide and produced 0.55 grams lead chloride. This one is the precipitate, itong na-produce. Pero how much chloride is present in the unknown? Ano ang nagbago dito? Kanina ang ginamit ko silver nitrate in the reaction. Kaya ang na-produce na precipitate is silver chloride. This time ang na-produce na precipitate class lead chloride, PbCl2. Ang magbabago class sa computation nito is ganito. Step 1, the same formula, percent chloride in precipitate is equal to atomic weight of the chloride divided by molecular weight of precipitate times 100. So again, the same formula. Pero ganito, PbCl2. Kung i-compute natin yung molecular weight niya, you have Pb, you have Cl, you have one lead. Pila itong atomic weight ni lead? 207? Tama ba?
Yes, ma'am.
207.
Okay, 207. Tapos, itong chloride, dalawa siya, times 35 equals 70. So, this is a total of 277 grams. So, you have here 277 grams. Pero the twist is you have to use 70 grams here for the atomic weight of chloride. Kanina 35 lang, right? 35. Kung titingnan niyo yung previous examples natin for chloride, 35 lang. Kasi silver chloride yun. Isang chloride lang ang meron sa precipitate. Pero kung titingnan natin ang new precipitate natin ngayon, PbCl2, meaning dalawang chloride ang present. So iti-take mo siya, i-consider mo siya sa computation na dalawa yung chloride na present in the precipitate. Kaya do not use 35 grams. Instead, use the 70 grams times 100. Pero the rest of the computation class, pareho na siya. So 70 divided by 277 times 100 is 25.27%. So, ganun pa rin yung computation. Ito lang yung gusto kong ipakita sa inyo. Na kapag dalawa ang chloride, ang sulfide, or whatever element is we are looking in the problem, you have to consider the atomic weight also. It will be doubled or tripled depende sa number of atoms ng element na yon sa precipitate mo. I hope that is clear. So the next succeeding steps are actually the same. The mass of the chloride in the precipitate, the mass of chloride in the precipitate will still be the same. It will still be computed as like this, percent chloride in precipitate times, what is the weight of the precipitate? Here, 0.55 grams. This is the weight of precipitate. So, ang computed is 25.27% times the weight is 0.55 grams. So, parehas na yan siya. 25.27 divided by 100 is 0.2527 times 0.55. That's 0.1390 grams. So, yun yung step 2. Ang step 3, parehas pa rin. Percent chloride in the unknown is equal to the mass of chloride in our precipitate divided by the weight of the unknown times 100 pa rin. So, mass of chloride in the precipitate is 0.1390 grams. The unknown is 0.98 grams times 100. Let's see, 0.1390 divided by 0.98 times 100. 2 decimal places, 14.18%. So, kung nakikita niyo sa screen class, all the remaining steps are the same. Ang nagbago lang is ito. Kasi dalawa yung chloride na nasa precipitate natin. Pero pag isa lang, so you really have to consider kung anong precipitate ang na-form. Kagaya ng silver chloride, isang chloride lang talaga yan. That's the time you use the 35. So I hope clear yan siya. Ito lang, binigyan ko lang kayo ng examples because I don't know with the exam kung anong precipitate ang ma-form. Okay? I still don't have a copy of the exam. Since we are on team teaching, sa prelim, ako'y nagbuhat sa exam. Pero karong midterm, I was not the one who made the exam. So I still don't have the copy of the exam until now. Let's just wait for it. si Ma'am Charm ang gumawa ng ng midterm exam. Pero sa laboratory, she was the one who made the laboratory exam last prelim. So ngayon yung aking assignment is ako na naman ang gagawa ng laboratory exam. Yan yung mangyayari sa midterm exam ninyo. Questions for this class? Any question or clarification before tayo mag-move on? So, Gora na as. That is for the gravimetric analysis. So, I hope you have appreciated how useful gravimetric analysis is in the identification of the unknown chemicals in the laboratory. Now, let's move on sa acid-base titrations. So this time, the acid-base titration is actually used to know the concentration of our substance. So in this case, we actually know the substance. Ang hindi natin alam ang concentration niya. So kung gusto nating malaman ang concentration ng ating chemical compound, then we can do titration. Okay, concentration ha, yung goal natin for titration is to know the concentration of our substance. So ang ginagawa naman natin here sa laboratory is we have compound letter A and then unknown yung kanyang concentration. Ipapareact natin siya with another compound, that's the compound B, pero this time this is known. Known ang kanyang concentration. So, syempre, magpo-produce yan siya ng product or products. Okay? Depende kung anong compounds ito. Okay? So, ang tawag class sa substance na known ang concentration is the standard solution. Ito yung sample natin kasi hindi natin alam yung concentration niya. But the one that is the solution with known concentration is called the standard solution. And we will have them react with each other until the reaction is complete. Okay? So, one example of a chemical compound that is always used in titration is sodium hydroxide. Again, this is commonly used in the laboratory, especially in titration. Now, what is the problem with sodium hydroxide? Sodium hydroxide is considered as hygroscopic. Let me write it sa screen. Sodium hydroxide is considered as hygroscopic. If you encounter this term, this refers to any substance that absorbs moisture from the air. Yung air natin, especially in the Philippines, we belong to zone 4 when it comes to climatic condition. Our climatic condition here sa Philippines is hot and humid, meaning our environment is very hot, actually is hot, but humid siya because it contains a lot of moisture. Ang air natin dito merong maraming water vapor to be exact. So itong si sodium hydroxide class, pag nilagay mo to siya example sa watch glass, pellets ito ha, pellets. So parang tablet na maliliit. Pag nilagay mo siya sa watch glass and you let it stand for how many minutes, hindi mo siya i-close, wala siya itabon. So ipastay lang yun siya sa table. Kadugayan class, you will see that this will liquefy. The solid becomes almost liquid pag ipastay mo lang siya, uncovered. So yun yung sinasabing hygroscopic kasi si sodium hydroxide will absorb the moisture coming from the air. And at the same time, sodium hydroxide is known to react with carbon dioxide also na makikita sa air. So kaya si sodium hydroxide na ginagamit natin sa laboratory, nagbabago yung kanyang concentration from time to time. Tapos 'di ba, pag nag-absorb na siya ng moisture from the air, water yun na na-add. And anong ibig sabihin pag nag-add ng water? 'Di ba? It's a dilution process. And pag sinabing dilution, nagbabago ang kanyang concentration. Kaya before using sodium hydroxide in any laboratory work, we have to standardize it first. By the way, the meaning of standardization, ma-encounter niyo siya even in your higher years or even while working as medical technologists. Pag sinabing standardization in the chemistry laboratory, it is referring to the determination of the concentration of the solution. So when we say we standardize first the sodium hydroxide solution before using it in any laboratory work, then it means that we have to know and determine first the concentration of the sodium hydroxide solution. Kailangan muna natin siyang gawin kasi nga nag-change yung kanyang concentration every time ma-expose siya sa air. Nadadagdagan ng water coming from the air or moisture coming from the air. So how do we do standardization of our sodium hydroxide? It's through acid-base titration. Because remember, sodium hydroxide is a basic substance. So ipapa-react natin siya kay acid para malaman natin ang concentration niya. I hope that is clear. Any questions so far about this? Alin dyan ang hindi naintindihan? I don't know if you have conducted titration during your high school years, pero I will try to explain it hangtod masabtan ninyo. Before ta mag-move on sa procedure sa titration, let me first define some terminologies associated with the titration. The first one here is the equivalence point. The equivalence point is actually a theoretical point where equal amount of acid has reacted with an equal amount of base. So kapag ka-equal na ang acid na nag-react doon sa base mo, equal na yung amount nila ha, equal na yung kanilang concentration na nag-react with each other, that's the time we call it equivalence point. Meaning yan, kung meron kang acid class, nilagyan mo siya ng base, itong lahat ng acid na neutralize na. But the process of the reaction between acid and bases is called neutralization. So kung na-neutralize na lahat ng acid or lahat ng base, equivalence point na yan siya. However, this is just theoretical. Kasi when we do titration, we cannot really observe the equivalence point. We don't have a way to know na, uy, equal na pala yung acid and base na nag-react. So ang ginagawa natin, nag-a-add tayo ng indicators sa ating solution. So indicator is actually another chemical substance na again ina-add natin doon sa solution, and anong function niya? Indicators actually change in color if there is a change in the pH of the solution. Again, itong indicators nag-change ang color niya pag merong change in the pH of the solution. So, mag-help ito para ma-estimate natin si equivalence point. Distinct kasi yung color niya kapag ka nasa acidic medium siya, iba ang color niya. Kapag ka nasa basic medium siya, iba din ang color ng indicator. Yan yung mga dapat kong i-discuss sa inyo. Wait lang, Han. I think I have here an example sa titration. This is how the titration setup looks like. You have there the iron stand, and then you have the burette clamp. Iko-connect mo si burette dyan, class. And the solution to be titrated is placed here in the Erlenmeyer flask. Another compound is to be placed here in the burette. And then yung solution, class, dito sa Erlenmeyer flask, lalagyan mo yan ng indicator. Para kapag ka nag-change na yung kanyang pH, kasi example, acid ito, base ang nasa burette. Pag add mo ng base coming from the burette, mag-change yung pH ng solution dito sa Erlenmeyer flask mo. Pag nag-change ang pH, mag-change din ang color ni indicator. So, if you look at the illustration, actually colorless yan siya, and then after some time, na nag-change ng pH, look at the color. It's color pink. And that signifies now na, endpoint na. We call it endpoint, meaning you have to stop the titration, you have to stop adding the solution coming from the burette. So that's how the titration works. Okay? Questions so far? Wala. Wait lang ha. Kajut lang. Nasabaan ko aning nag-meeting. Kajut lang. Okay, let us continue. Now, if we want to standardize sodium hydroxide, if we want to know the concentration of sodium hydroxide, the acid that can be used in the titration is potassium hydrogen phthalate. That's the name, ha? Potassium hydrogen phthalate, or we abbreviate this as KHP. Sometimes this is called potassium acid phthalate. Isang chemical substance lang yan sila. Now, this is a monoprotic acid, meaning meron siyang isang hydrogen that is capable of being ionized. The molecular formula of our potassium hydrogen phthalate is KHC8H4O4 with a molar mass of 204.2 grams. This is not this is not rounded off. Ito yung kanyang chemical formula. You can try solving for the molecular weight of potassium hydrogen phthalate. It's just that hindi na round off itong given na molar mass coming from the book. So we have a lot of potassium acid or potassium hydrogen phthalate in the laboratory where we can use in the standardization of our sodium hydroxide. It's actually white and soluble in water, and most likely it's highly pure. Now, if ipa-react natin siya kay sodium hydroxide, class, ito yung magiging chemical reaction niya. This one, KHC8H4O4 is the potassium hydrogen phthalate. Magre-react siya with sodium hydroxide, forming the potassium sodium phthalate plus the water. So actually, ang magre-react lang dyan is the phthalate na ion, yung hydroxide na ion, forming the phthalate ion pa rin. This one is the hydrogen phthalate ion. Itong C8H4O4 -2 is the phthalate ion plus the water. Pero yung procedure sa titration, anong ginagawa niyan? First, mag-weigh tayo ng amount of KHP or potassium hydrogen phthalate. Ilalagay natin siya sa Erlenmeyer flask. Tapos, dadagdagan natin siya ng distilled water to make a solution. Remember, KHP is soluble in water. Tapos, pag andun na siya, class, sa Erlenmeyer flask, the next thing that we will do is we are going to place the sodium hydroxide solution in the burette. Okay? Sa burette natin siya ilalagay. Tapos, i-add natin yung sodium hydroxide from the burette going to the Erlenmeyer flask na merong potassium hydrogen phthalate solution until we reach the equivalence point, though we cannot really see the equivalence point, but to be exact, it's the end point. Kapag ka nag-change na ng color yung solution, and na, you have to close the burette and stop adding more sodium hydroxide. So ang ibig sabihin nun, you will have equivalent na amount of KHP na nag-react with sodium hydroxide, and that the neutralization reaction is already complete. Now, to have the change in color, do not forget na we have to add indicator first half before ka mag-add ng sodium hydroxide, indicator muna. And most of the time, we use the phenolphthalein as the indicator. So phenolphthalein indicator yan siya. That's the name of the indicator na ginagamit. Now, si phenolphthalein kasi kapag ka nasa acidic solution siya, kagaya ng i-add natin siya doon sa KHP. Now, KHP is acidic. So, colorless si phenolphthalein. Pero kapag ka nasa basic medium na siya, pag in-add na natin yung sodium hydroxide which is basic, pag na-neutralize na lahat ng acid, tapos you will have more sodium hydroxide, si phenolphthalein will turn into reddish pink. So the end product will become like this, as you can see in the picture. So that's the use now of phenolphthalein. Yeah, mauna siya. Ang sodium hydroxide ang nasa burette, si phenolphthalein ina-add doon sa Erlenmeyer flask. So ito yung setup natin sa titration. So I think I cannot finish this, but let me just see if I have a video here sa before tayo mag-end, before ta maniud to.